My name is Tea and I am a heritage scientist in the conservation department of the Schmollin Museum. I look at the material of art and archaeology objects. The Great Bookcase is a big piece of painted furniture that was designed by the architect William Burgess, who gathered together 14 different artists to paint it. Among them were Simeon Solomon, Henry Stacy Marks and Edward Poynter. The bookcase was designed to be the centerpiece at the medieval court of the London International Exhibition in 1862. It is divided horizontally in 3 different structural parts. The middle part is decorated with a mosaic of 8 painted panels depicting Christian and pagan themes. The composition is closed to the top by 3 female figures representing art, flanked by love and religion. From a technological perspective, the Great Bookcase was painted in a fascinating period. Ever since the Industrial Revolution started in the late 18th century, the production of painting colors shifted from within artist studios to large-scale factories. Thanks to this process, expensive pigments such as the deep blue traditionally obtained from the stone lapis lazuli were now available on the market at a much cheaper cost. It was the start of a color revolution. Burgess started working at his bookcase in 1859, right in the middle of this color revolution. This is why the pigments of the bookcase are so worthy of being studied. Their characterization could tell us more about the choices of the artist regarding the materials to be used. Were they happy and excited to experiment with new materials, or they decided to use traditional pigments that the artistic community was more familiar with thanks to centuries of practice? And also, did each artist use his own materials, or was it Burgess controlling these technical aspects? We decided not to dismantle the bookcase into its 3 structural sections and not to move it from the gallery to prevent any possible physical distress. We approached the analysis using mainly methods that do not require the extraction of samples to preserve the physical integrity of the objects. We used several analytical techniques, each one providing a small piece of complementary information, and we performed the analysis directly in the gallery. The bookcase measures roughly 3 meters by 2. Its size posed the greatest challenge for analysis. The Schmollin Museum cooperated with the departments of Engineering, Earth Sciences and with the University of Durham. The collaborative effort of a team of scientists, conservators and museum technicians was needed to carry on this project. In fact, while the lower panels were easily accessible from the floor level, the top panels were too high and required a scaffolding tower and a tailor-made aluminum frame to be assembled in the gallery. Sadly, this technical operation was severely slowed down by the pandemic, as it limited the number of people who could work closely together, and it restricted traveling and access to the university buildings. The painted surface of the bookcase was initially examined using a USB microscope connected to a computer. This way, we could observe different colors through the cracks of the gold and blue background on the bookcase, suggesting that the background was actually laid at the end rather than at the beginning, as it is usually the case. And using this microscope, we could also follow through the blue brushstroke around the figures on many of the panels. We used an infrared camera to observe the underdrawing and any possible details that could have been hidden when the gold and blue background were laid down. We found out that many of the panels were originally set in a different environment. For instance, the panel with the story of Fra Angelico was originally set in an outdoor space, as the infrared picture shows a stone wall with some ivy. In contrast, the panel with the myth of Pygmalion showed a horizontal bar with a drapery hanging behind the whole scene, much like the curtain of a theatre stage. Only in few cases, we extracted few microsamples from the bookcase and we analyzed them using benchtop equipment in our labs to obtain more accurate information. We took few microsamples using scalpels. The samples were really tiny. They measured roughly 1, maximum 2 millimeters in size. We embed them in resin and then we polish them to reveal their cross-section, which is the stratigraphy of the different paint layers used on the bookcase. The analysis of these microsamples revealed very interesting results. It showed that many of the colors used for the bookcase were actually a mixture of different pigments. The size of the particle and the homogeneity of the mixture suggest that they were prepared industrially. This means that the artists were actually purchasing pigments in paint tubes rather than mixing them on their own palette. In fact, they might have been unaware of the materials they were using, as paint tubes were often sold on the market, tagged with rather misleading labels that were only vaguely describing the composition of the color they contained. The investigation of the Great Bookcase is still ongoing, and it aims to understand much more than just the material characterization of pigments. We are researching the personal choices of a group of artists who lived through a period of great change and who had to face a dilemma that many people encountered throughout history: preserving tradition or pursuing innovation.